Good day, viewers. In this virtual class, let's take a look at this question. It says if x plus 1 over s is equals to alpha, express s raised to power 5 plus 1 over s raised to power 5 in terms of alpha. Here, first of all, let's look for a generalized form of um, this function. We say let Pn is equals to s raised to power n plus 1 over s raised to power n. Now, let's first of all find an expression if n is equals to 0. Now, if n is equals to 0, we substitute in place of n here 0. This become p 0 or p naught is equals to s raised to power 0 plus 1 over s raised to power 0, and that eventually gives 2. Now, let's try when n is equals to 1. So this become p1 is equals to s raised to power 1 plus 1 divided s raised to power 1. And you see that s raised to power 1 is the same thing as x. This becomes x plus 1 over s. We know that s plus 1 over s is equal to alpha. Okay, so the p1 is equal to alpha. Now let's find an expression. Let's find an expression by multiplying alpha by Pn. Okay, so here we know that alpha is x plus 1 over x, and Pn is s raised to power n plus 1 divide s raised to power n. Now, if we diligently uh, do this expansion, it becomes x into x raised to power n plus 1 over s raised to power n, a close bracket, plus 1 over x into x raised to power n plus 1 over s raised to power n. Now, if we multiply here, x times s raised to power n gives s raised to power n plus 1. Or similarly, s times 1 over s raised to power n will give 1 over s raised to power n minus 1. Okay, from indices. Or similarly, 1 over s multiply s raised to power n will give s raised to power n minus 1. Okay, now 1 over x multiply 1 over s raised to power n will eventually give 1 over s raised to power n plus 1. Now, if we tend to group them, you will see that this become s raised to power n plus 1 divide s raised to power n plus 1. Okay, on this side we have the s raised to power n minus 1 plus 1 divide s raised to power n minus 1. Okay, and if you look at this here, we are just having s raised to power n plus 1, s raised to power n plus 1. This one is s raised to power n minus 1, and plus 1 over s raised to power n minus 1. So we can confidently say that s raised to power n plus 1 plus s raised to power n plus 1 divide 1 over s raised to power n plus 1 is p n plus 1. Okay, from the our initial expression here. So we're just having plus 1 here. So it's going to be pn plus 1. Similarly, in this expression here, s raised to power n minus 1 plus 1 divide x raised to power n minus 1 become pn minus 1. So that alpha times pn plus 1 is equal to p alpha times pn is equal to pn plus 1 plus pn minus 1. Okay, now we are trying to look at s raised to power 5 plus 1 or over s raised to power 5. Now, first of all, how do we go about that? We look for how to generate that by looking at some values of n. Now, assuming we have n up to 4, because of we're having pn plus 1 here. So if we put 4 here, so we're going to have a p 5 plus p 4 times p3. This is p3 is equal to alpha times p 4. Okay, now, but what we do first here, this is our derived formula here, okay, where we multiply alpha by pn. So let's assume that n is equals 1. When n is equals 1, this expression become alpha times p1 plus here become p2 plus P naught, because 1 minus 1 is 0. So we could already obtain the value of P1 as well as that of P naught. Okay, so that here we're looking at P2. So P2, if we move all this variable here, so P2 become alpha times P1 minus P naught. But we have already know that P1 is the alpha and P naught is 2 from our initial expression there. Okay, now so that P2 becomes alpha times alpha, which is alpha square minus 2. Okay, when n is equals to, we have P3 is equals to alpha times P2 minus P1. So we are equally putting it in this um, expression here, equation. So if n is equals to 2 here, what will become of this expression? It will become P3 is equals to A times P2 minus P1. Because we have known the expression for P2 and P1, we will substitute it, and it becomes P3 is equals to alpha. P2 is alpha square minus 2, and P1 is already known to be alpha. Okay, so that P3 is equals to alpha raised to power 3 minus 2 alpha minus alpha, that become alpha cube minus 3 alpha. So now let's assume that n equals 3. So that putting in this expression, it become a alpha times P3 is equals to here, if we put 3 here, this become P4 plus P2. So that for us to obtain P4, we make P4 subject to the formula, they become alpha times P3 minus P2. We know that P3 is alpha cube minus 3 alpha. So we substitute it here, and this become P4 into P4 is equal to alpha into alpha cube minus 3 alpha close bracket minus in place of P2 is we know that P2 is alpha square minus 2. Okay, so that P4 is equal to alpha raised to power 4 minus 3 alpha square minus alpha square plus 2, and this eventually become alpha raised to power 4 minus 4 alpha square plus 2. Now for us to obtain P5, we look at when n is equal to 4. So when n is equal to 4, we have alpha times p in place of Pn, which is P4. Then in place of n here, put n here, this become P5 plus P3. So that P5 is equal to alpha times P4 minus P3. We know that the value of P4 is alpha raised to power 3 minus 4 alpha square plus, and the value of P3, the expression for P3 is the alpha cube minus 3 alpha. So that opening this expression here, so that our P5 is equal to alpha raised to power 5 minus 4 alpha cube plus 2 alpha minus alpha cube plus 3 alpha. So multiplying alpha through in this bracket will give this expression here. Okay, up to this point. Why this minus will open this become minus alpha cube plus 3 alpha. So simplifying the expression here, this become P5 is equal to alpha raised to power 5 minus 5 alpha cube plus 5 alpha. Okay, this is typically the value of the expression s raised to power 5 plus 1 over s raised to power 5. So please, there's other way you can do it, but this is more unique. Please, if you like this video, help me subscribe and also share on this video on your social media platform. Have a nice time. See you in my next virtual class.